This project is to fulfill the big idea 1 in a learning objective, distribution of electrons in an atom. In this project, I'll be practicing the shell and quantum mechanical model, also the electron configuration and electron structure of atoms. Terms being used are atoms, valence electrons, and orbitals. Now, I'm going to talk about the Bohr's atomic model. In this model, the yellow beads represent the electrons. The nucleus is in the center and surrounded by the orbitals, which are blue circles. We can use a formula to predict the maximum number of electrons that can fit into an energy level, which is 2n squared. The letters K, L, M, and N represents the energy level. This is an example of Bohr's model of oxygen. We know that oxygen has an atomic number of 8. So it has 8 electrons. Because oxygen has 8 electrons, it has 6 valence electrons in its outermost shell, which is represented by the green beads. However, Bohr's model had limitations. Electrons have a wave nature, and the exact location of electrons cannot be specified as proposed by Aaron Schrödinger. Now I'm going to conduct an experiment to have an idea of Bohr's atomic model, and also to find the probability of the location of electrons. In order to conduct this experiment, I drew 5 circles and the center with the large dot represents the nucleus. I counted 100 dried beans and put them in a funnel. Now I'll allow the beans to fall through the funnel onto the paper target. We can see that most of the beans are further away from the nucleus. Also, the beans' distance from the nucleus in terms of other beans varied. From the data, we can see that in ring 2 there are 53 beans and in ring 5 there are 5 beans. In this experiment, the beans represented the negatively charged electrons in an atom. It was not possible to determine the exact path of an electron in an atom. This is because electrons have a dual nature. It acts as a wave and also as a particle, so the exact path of the wave cannot be determined. This finding relates to the quantum theory, which states that it's extremely difficult or impossible to determine the exact path of an electron, which is known as the uncertainty principle. Now, within each energy level, there are sublevels, which are represented by S, P, D, and F. Within each sublevel, there are orbitals, where there is high probability of finding electrons, and each sublevel has a defined orbital. This is an electronic configuration of oxygen. Oxygen has an atomic number of 8, so it fills up the energy level using the Hund's rule and the Afubu principle. Now, oxygen has one s orbital and a 3p orbital, so the hybridization of oxygen is sp3, which gives a tetrahedral arrangement. The solution to the Schrödinger's equation are characterized by the 4 quantum numbers. Now, this is a quantum number of oxygen. Since oxygen has an atomic number of 8, it fills up 2 energy levels, so the principal of energy level for oxygen is 2. The angular moment of number is 4. So since it has a p sublevel and the angular momentum of p sublevel is always 1, the magnetic quantum number is -1 and the spin quantum number is -1/2, since there's a spin in the p orbital. There are 2 models of an atomic structure in use, which is the Bohr model and the quantum mechanical model. Electrons orbit the nucleus in circles called the energy level, and inside the energy level are sublevels. Inside the sublevels are orbitals.